Okay, so in the last video we learned this sum formulas for sine and cosine. So I've got a new sort of problem up here. I want to evaluate cosine of s plus t, and I'm not telling you exactly what s and t are, but here I'm telling you that sine of s is 3/4, and s is between pi over 2 and pi. Now notice that's putting it in quadrant 2. Okay. And then I'm telling you that cosine of t is negative 1/3, and t is between pi and 3 pi over 2. So that's going to put me in quadrant 3. Okay. So I know that cosine of s plus t, I can just plug into this formula. I've got s in place of a and t in place of b. And I'm thinking cosines are antisocial, so it's cosine cosine, because they're putting themselves first. So it's going to be cosine of s times cosine of t minus sine of s times sine of t. So I've got to know these four things. Now, two of them were given. So it looks like for s, I'm going to have to figure out what cosine of s was. But I was told that sine of s was 3/4. So I can go ahead and plug that in. Now for t, I was told that cosine of t was negative 1/3. Sine of t, I'm going to have to figure out. Okay. So two of the four values that I needed were given. Now let's figure out the rest of them. So for s, we were told it was in quadrant 2. Okay. So I'm going to draw it as an obtuse angle. It could, of course, rotate around multiple times, or it could rotate in the negative direction, but I've sort of got that. I'm going to let alpha be its reference angle. Okay. And then I've got this nifty right triangle. So I know that sine of alpha is the absolute value of sine of s. It's just 3/4. Okay. So with the reference angle, everything's just always positive, which is why I'm taking the absolute value. But now I can say I know that sine would be opposite over hypotenuse. So I should be able to solve now for this adjacent side just using Pythagoras. So I know that a squared plus 3 squared equals 4 squared. That's a squared plus 9 equals 16. A squared is going to equal 7. A, because it's a side length, is positive square root of 7. Okay. Now I'm choosing to label the side lengths for the reference angle alpha. If you prefer to label signed side lengths for the angle s, you can. I'm going to, however, just evaluate now. I wanted cosine of s, so I'm going to do that in my usual two-step process. I'm going to say, well, I'm in quadrant 2. If I'm in quadrant 2, I know that cosine is going to be negative. And then the absolute value that I attach to that negative sign is cosine of alpha, which is just adjacent over hypotenuse. So that's going to be root 7/4. So I'm able to figure out cosine of 7 is negative root 7/4. Now I need to do something similar to figure out what sine of t is. So I was told that t was an angle in quadrant 3. So I'm just going to draw it like so. Alpha, again, will be my reference angle. And if I drop a perpendicular to the x-axis, I get a right triangle with my reference angle in it. Now, I know that cosine of alpha is going to be the absolute value of cosine of t. So that's the absolute value of negative 1/3, or 1/3. Okay. So I can say the adjacent side would be 1. The hypotenuse would be 3. I'm going to label the opposite side p. Okay. And then I can say 1 squared plus p squared is equal to 3 squared. 1 plus p squared equals 9. P squared equals 8. P, again, I'm solving for just side lengths. I'll deal with the sign separately. So p will be the positive square root of 8. And that's the square root of 2 times 2 times 2. Pair of 2's, I can pull a 2 out. So that's going to be 2 root 2. So instead of writing p, I'll write it as 2 root 2. So now I wanted to know what is sine of t. So again, I can do that as my two-step process. I'm in quadrant 3. So in quadrant 3, sine's going to be negative, and the absolute value that I will attach to that negative sign will just be sine of alpha, which would be the opposite, 2 root 2 over the hypotenuse 3. So 2 root 2 over 3. So now I can fill in here negative 2 root 2 all over 3. So I had to do a little bit of work to figure out some of my trig functions, but now that I've done that, it's just a question of doing the arithmetic to simplify this. So let's see, this is a negative times a negative, so it's going to become positive, root 7 over 12, minus, but I've got another negative, so that's going to become positive as well, 6 root 2 over 12, and then I can say that's going to be root 7 plus 6 root 2 all over 12. Now, you might be tempted to cancel the 6 and the 12. We cannot cancel across addition. If you wanted to keep it as two separate fractions, I could cancel the 3's and I could cancel the 2 here. So if I wanted to, at this point, when I had two separate fractions, I could have said root 7 over 12 plus root 2 over 2. I could have canceled here while it was a separate fraction. Either of these answers would be perfectly acceptable. These are both considered fully simplified. Here I just wrote it as one fraction, here two fractions.